In our experiment, we tested whether the color of highlighted words would affect memory. Our hypothesis was that the yellow ink will result in the largest amount of terms remembered. After performing our experiment, the yellow highlighted words had the greatest average for the number of terms remembered.
The working memory is a system that allows you to remember a limited amount of information for enough time for the information to be useful. This short-term memory is useful for when you need to remember a phone number, a few names, or a few directions. The working memory is not a space to hold information for very long. According to Miller, most adults can store between 5 and 9 items in their short-term working memory. This is called the magic number 7 rule. The theory states that on average, an adult can remember around 5 to 9 words, phrases, or number at a time. The central executive part of the prefrontal cortex at the front of the brain plays a fundamental role in short-term and working memory. It both serves as a temporary store for short-term memory, where information is kept available when it is needed for current reasoning processes, but also calls up information from elsewhere in the brain. To remember the information and be able to recall the words or phrases, people tend to use a chunking technique in order to memorize words easier. The chunking technique allows someone to pair up or group words or numbers to remember them easier. For example, finding 2 words that relate to each other and creating meaning out of the 2 words together is an example of this.
There have been multiple studies that investigate the relationship between memory and color. In one study, research has shown that specific interventions involving colors can be introduced to deal with memory-related problems such as learning difficulties, autism, dyslexia, and others. For people with these problems, the use of color made it easier for them to read, as shown by clinical interventions for patients with dyslexia and autism. Difficulties that patients with dyslexia had with reading were reduced in situations where the text had color overlays. The same approach was used for patients with autism, and the reading speed of these patients improved by 35% when they were reading with color overlays as compared to the reading speed when no color overlay was used. This shows that color improves the ability of people to read when they have problems with their memory, leading to a conclusion that color affects memory. Another study shows that differences exist between colors with hue and colors that are shades of gray and black on the retention rate on a list of words. The study shows that there is a basis for associating color with improvement of memory abilities. The list that had hues showed better retention rates over the rate that was shown with the recall on the list with black and gray texts. This leads to color having the potential to increase the chances of environmental stimuli to be encoded, stored, and retrieved successfully. The choice of colors and the manipulated aspects of the experiments can influence the extent to which colors can influence the performance of the human memory. This shows that ranges of color have different effects on memory and retention. Due to multiple studies, it has been found that color increases a person's arousal, and arousal can increase memory, so then there is the possibility that color can increase memory. It was proposed that warm colors, such as red and yellow, increase arousal more than cool colors, such as green and blue. In one experiment, participants were given a series of tasks on different colors of paper and then asked to remember the list of words that they memorized prior to the tasks, one of the tasks being a math problem. The data shows that there was no statistically significant difference for the percent recall among the color categories. Recall percentages for the warm category were 43.5%, and percentages for the cool category were 45.7%. The study was conducted using different colored papers, leading to a conclusion that the color of the paper had little effect on the memory of the participants. The color of the words may produce a different result, which leads into our study.
This is a topic that really drew us to experimenting with color because of the popularity of highlighters and how many are bought off the shelf every year. People continually to use highlighters to mark up their papers in hopes that they will remember what they marked in the future. The color yellow from the highlighter is meant to stand out and help improve the retention rate of what has been highlighted. This study that shows the color of the paper has no effect on memory. If the entire page is one color, nothing will stand out and catch a person's attention in hopes that they will remember it better. Does highlighting in colors actually lead to a better chance of remembering what needs to be remembered? If the list of words was highlighted in yellow, then the person taking the test would memorize more of the words. Yellow is the most common highlighter color that people use and that is bought. Yellow highlighters are sold individually and come in packs of only yellow highlighters, whereas other color highlighters come together. Example, pink highlighters are typically found with orange, yellow, green, and blue. Pink highlighters are not often found in packs of only pink highlighters. Since yellow is found most often and is most often used, the color yellow leads to better retention and the recall of items that have been memorized by people. We believe that the most words will be recalled correctly from the list of yellow highlighted words because of the common use of highlighters in schools, offices, and homes.
Our independent variable was the color of the text highlight, and the dependent variable was how well the words are remembered/recalled. And the way we defined this was by the average number of words remembered for each color, and specifically for each data point, we counted the number of words that were written down that matched with the original words from the list, so essentially the correct words that the participant produced. And the control group was a group of 5 people with black text with no highlights. The constants that we held in the experiment was the amount of time given to look, record, and remember the terms, the writing utensil, which was a pencil, and the words in each list, which was the same 15 words for each participant. The confounding variables was the setting the person which was in, which varied from time to time, and whether or not they were talking to other people, and the time of day they were asked to memorize. Since we did take this experiment in school and after school, the time of day that people were asked also varied. But in an attempt to standardize this, we took most of the data during lunchtime around the same atmosphere. The materials that we used include blank lined pieces of paper, 1 fresh for each participant, a pencil, a timer, and 4 lists of 15 words, 1 list with black text and no highlight, another with yellow highlight, red highlight, or blue highlight. The lists that were mentioned previously are seen here. Experimental procedure. The first step was to gain the consent from the participant and explain that A, they will receive 30 seconds to memorize a list of 15 words, and then they will receive 1 minute of off time without the paper or any writing instrument. And then lastly, they will receive 1 minute to receive a paper and pencil and to write down all the words that they recall. And then the second step after explaining would be to execute this procedure and to give a 5-second warning for each time session. And then lastly, it would be to record the data without revealing personal information of the participant. Sampling and ethics. For our sampling, we did resort to using convenience sampling, as much as we wanted to draw from all age groups, sexes, and occupations, the sampling was not indeed random or representative or large enough, since we did resort to going to people that we knew or those that we were related to. For consent, we received all the consent for the participants that were eager and willing to participate in our experiment. As for confidentiality, the results of the participants were anonymously recorded, and the results were not shared with any other parties as to maintain the personal information of the participants. The participants were debriefed about their scores, and they received their scores if they desired, and they were also explained the premise of the research, what it was designed to find, and how their participation will be used or distributed, as well as what our research hoped to find.
Results. The average number of words remembered for our control was black, which was 7.6. The yellow text had an average of 8.4, the average for the red text was 6.6, and the average for the blue text was 7.4. This is a summary of all the data collected during the experiment. These are the graphical representations of the number of words remembered by each person in the red and yellow groups. These are the graphical representations of the number of words remembered by each person in the black and blue groups. This graph shows the average number of terms remembered by each group.
In order to determine whether or not this hypothesis was supported or rejected, we used a chi-squared test of statistical analysis on our data. In order to do this, we first looked at our observed values, which are the averages for the number of words remembered in each of the 4 groups. Then we looked at the expected value and compared it to the observed value. In the introduction, we stated that people remember 5 to 9 words in their short-term memory. Because 7 is the median of this range of numbers, we chose 7 to be our expected value. Based on our calculations, we found that the chi-squared value is 0.377. The degrees of freedom are 3 because there are 4 sample groups, and the p-value is 0.05 because we are doing this test with 95% confidence. Based on these 2 values, we determined that the critical value was 7.82. Since the chi-squared value of 0.377 was lower than the critical value of 7.82, the null hypothesis cannot be rejected, and it can be concluded that there was no difference in memory using different highlighter colors. In addition to testing the average number of words that people remembered in the 4 experimental and control groups, we also tested for certain characteristics that the words could have, such as levels of processing, distinctiveness, and chunking, in order to determine the strength of retrieval cues. In order to do this, we added words to each list that would test for each of these 3 specific categories. For example, in order to test levels of processing, we added a word, jeans, that we hoped that the blue group would remember since jeans are blue. And we did the same for the red, yellow, control group, and for distinctiveness and chunking. In levels of processing, 1 person in the blue group remembered jeans. 0 people in the control group remembered night. 2 people in the red group remembered fire truck, and 3 people in the yellow group remembered sunshine. Based on these results, we see that less than 50% of the people in all of these groups remembered their respective word based on the levels of processing. So we can say that it is not significant. For distinctiveness, we added the word flabbergasted, and 13 out of 20 people were able to remember this. Since more than 50% of the people were able to recall this word, we could say that it was significant. We also added 2 words, jeans and sweater, that could be put together in order to test chunking, since jeans and sweaters go together. Of the 20 people, 6 were able to recall both of these words. And since this is less than 50% of the participants, we can say that it was not significant. Moreover, incorrect words were added. 4 of 20 added words that weren't on the list, including fantasy, crow, queen, and sun. Sun, for example, is very similar to the word sunshine on the list, but the other words like fantasy, crow, and queen are not. Sources of error. There were a couple of sources of error in our experiment, most of them coming from the small sample size and the lack of standardization. Since we used a convenient sample instead of a random sample or a stratified sample, every member of the population did not have an equal chance of being selected, and only those who were close friends or family of the experimenters had a chance of being selected. This contributed to selection bias. We also had a very small sample size of 20 people. Because smaller sample sizes have high variability, meaning it's easier for a single person with a very good memory or someone with a very poor memory to affect the data. These sample sizes also have low reliability, which could lead to bias. Small sample sizes are also not as representative of the entire population. Moreover, during the 1-minute break period, after seeing the words for 30 seconds and before writing them down, some participants spoke during the 1-minute break, even if they were told not to. Because of this, some of the participants had lower memory scores, such as person 5, who received a score of 4 in the test with the color blue. In addition to sources of error, we also had sources of bias. For example, many of the participants in the study, before starting the test, announced that they were not good at memory tests or that they had a better memory at a different time of day. Because of this initial bias, they were more likely to put in less effort in memorizing the words and continually talk during the break period instead of concentrating on remembering the words. Because of this, they had lower than average scores. 2 examples of this are person 5 and person 3 in the blue group. This is known as a self-fulfilling prophecy. There was also experimenter bias in this research. The experimenters were doing the research on their family members and on their friends. Because of this, they might have unconsciously been more hopeful that their subjects would memorize more words than they would if the experiment had been implemented on strangers. This could have affected results and how much time was given to each participant. Also, many of the participants used different types of memory techniques. For example, some people used a phonological loop where during the 1-minute break period, they repeated the words over and over in order to memorize them before writing them down. Others use mnemonic devices and because of it were able to better remember the words. Using the words on the list, they formed sentences or they formed mental images. This could have skewed the distribution because of it would have led to better encoding. The next steps. If we were to repeat this experiment, there were several things that we would improve on. First being the sample size. If we had a larger sample size of at least 500 people selected by random sampling methods and then assigned into experimental and control groups by random assignment, this would better represent the population, and it would control for biases that we saw previously, like the self-fulfilling prophecy and experimenter bias that influenced the study. Moreover, it would have been better if this experiment were more standardized. It should have been done in large groups with a standard set of instructions with strangers or people that the experimenters did not know. In one-on-one tests, as we did in this experiment, the subjects often did not follow the instructions of remaining silent since they knew the experimenter. In a group, the subjects will be more likely to obey authority, which is in this case is the experimenter, and perform the test correctly. It would also be helpful to do further research on how a variety of different highlighter colors on a single list of words can affect memory, since that more accurately represents the use of highlighters in studying. Real-life implications. People often like to color code their notes using highlighters. Based on the results of this study and the statistical analysis, the use of highlighters does not affect memory, but this cannot be concluded definitely because of some of the sources of error we had, such as unstandardization and the small sample size. Our list also included warm and cool colors. As mentioned in the introduction, in previous psychology research, it has been found that warm colors are correlated with better memory since warm colors evoke arousal. This trend was not found in the data, as those in the red and yellow group, which are warm colors, had an average of 6.6 and 8.4 words respectively, while the blue group, which is a cool color, had an average of 7.4 words. The yellow group supports the previous research, while the red group does not, making it inconclusive.